Welcome to Maths with EJD. We progress to talk about Laplace transform for second order differential equations. We already have a kind of pattern following from the first order equation. So let's just take it deeper and see how this goes. Um, it's an overview. Again, the Laplace transform is a powerful tool for solving second order differential equations. Particularly dealing with initial value problems. Okay, it converts differential equations into algebraic equations, like we've always known, into algebraic equations, which are easier to solve. So let's look at the general form. I mean, we've seen this a lot under the differential equations playlist. So a second order linear differential equation with constant coefficients, with constant coefficients. So because if you have variable coefficients, then we have to use series method solutions. So equation with constant coefficients is given by ay prime prime of t plus by prime of t plus cy of t equals f of t. That's the general form. We've seen that a lot with initial conditions. Y of 0 equals y naught. Y prime of 0 equals y1. Okay. So we can then talk about taking Laplace, right? Taking the Laplace transform of both sides. We have L of a y prime prime of t plus b y prime of t plus okay, L of by prime of t, the Laplace of by prime of t plus the Laplace of course we take the Laplace of everything, and it is linear, so we can just take it one after the other too, like that. So that is c. Okay, I mean, what I should really do is everything together, then I can now do other things, right? So we have L of ay prime prime of t plus by prime of t plus cy of t equals L of f of t. Okay, so in this case now we just have a Laplace of y prime prime of t plus b Laplace of y prime of t plus C, Laplace of y of t, and Laplace of f of t on the right-hand side. And if we have this now, we can have this. So this is now a into, for the first one now, because it's second order, so a into s squared y of s, then minus s into y of 0 minus y prime of 0. Okay, we have, that's for this part now. Then for the next one, we have b into, in fact, I think I want to use, I want the brackets to be more representative. So b into, then y prime of t, that will now be s y s, s y of s, because it's one order, so s is just power 1, s y s minus y of 0, okay, minus y of 0 in that case, plus c, y of t is simply, y of t is simply y of s, y of s. And for the right-hand side, L of f prime of t, we just take f of t into the s domain. So that will be f of s. So in this case now, our focus is to solve for y of s, right? So we rearrange to solve for y of s. If you rearrange to solve for y of s now, so that will simply be, everywhere you see y of s, just put them together, right? Um, so there's y of s here, there's y of s here, and there's y of s here. So look at their coefficients too, that will be useful. So we have y of s into, here you have a of as squared, another y of s here has b, so you have bs, and lastly you have just c there, and then you can put other things to the other side. So you have f of s now equals, f of s plus, a, this is minus. So we have, okay, well, if I can break it apart, right? This is like, let me just break it apart so we can see clearly. So I'll just do that quickly. So we have as squared y of s, then minus as y of 0 minus a y prime of 0 plus bs y of s minus b y of 0 plus c y of s equals f of s. Okay, so with this, what we've done now, so y of s, y of s, y of s. So we just factorize. We have as squared as squared plus bs plus c already there. And now for the other side, you have f of s now minus. So you see that all these ones now, they have a to them. So we can factorize, right? So we have f of s plus a is common into sy of 0 minus y prime of 0. Okay, what else do we have? We have by of 0. So that would just be by of 0, like that. So it's minus, so it becomes plus on the other side. So we can make y of s the subject. So y of s now is equal to f of s plus a. And of course, from what we already know, right? From what we know from here, y of 0 is y naught, y prime of 0 is y1. So we can do that at this point. So we have f of s equals, in fact, we could just do that straight to this point, but it's okay. So we have a into y of 0 is y naught minus y1. Okay. Okay. Yeah, this is this. So it should be plus here. So it's plus y1. And then what else do we have? Then we have by of 0. That's by naught also. Okay. All of this divided by as squared plus bs plus c. So we have this expression right now that we can deal with. Now let's take a practical example so we can get the gist better. Let me go green and then do this here. Okay, so example. So solve y prime prime minus 3y prime plus 2y equals e raised to power minus t. Y of 0 is 1. Then y prime of 0 is 0. Y of 0 is 1. Okay. Y prime of 0 is 0. Okay. So what do we do? First, taking the Laplace transform, So we have the Laplacian of y prime prime minus 3y prime plus 2y equals the Laplacian of e raised to power minus t. Okay, so next we have the Laplacian of y prime prime minus 3 Laplacian of y prime plus 2 the Laplace of y equals Laplace of e raised to power minus t. So we can go now and deal with that. This is, okay, I want to switch. This is now s squared y of s minus s y of 0, okay, minus y prime of 0. So you see the power of s decreasing that way. S squared with y of s, then minus s with y of 0, then minus y prime of 0. Okay, so it's minus all the way there. Then minus 3 into the Laplace of y prime again, because it's order 1, so we have y of s, then minus y of 0 directly, no s anymore. And then for the last one, we have 2, then this is just y of s. Okay, so that's 2 into y of s. And for e raised to power minus t, of course, the rule is that's e raised to power minus 1t. That's 1 over s plus 1 already. So let's tidy things up. Let me take the pain to, just write things out. S squared y of s minus s y of 0 minus y prime of 0 minus 3s y of s plus 3y of 0 plus 2y of s is equal to 1 over s plus 1. But we already know, we know y of 0 is 1, y prime of 0 is 0. Okay, so this is s squared ys. So y of 0 is 1, so we have s times 1, so that will be s minus y prime of 0 is 0. That looks good for us. Minus 3s ys plus what again? 3y of 0. Y of 0 is 1, so 3 times 1. This is s times 1. This is 3 times 1 plus 2y of s. That is 1 over s plus 1. So again, we have s squared y of s squared y of s minus s, 0 is gone, minus 3s y of s plus 3 plus 2y of s equals 1 over s plus 1. So at this point, we can put all the y's together. So we have y of s, and y of s. So we see that y of s into s squared. We have 5s into s squared minus what else? Minus 3s plus 2. Okay, and that will be equal to 1 over s plus 1. Then minus s here goes to the other side to become plus s. So this goes minus, what else goes? 3 also goes. Now this 3 now, yeah, minus 3. This 3, this 3 is, it should be plus 3, right? So when it goes to the other side, it becomes minus 3. Yeah, it's plus 3, so it becomes minus 3. It becomes minus 3 here. Okay, so To get that working, we need to tidy things up. So this is y of s into s squared minus 3s plus 2 equals the LCM here. If you take this over 1 all the way, this is s plus 1. So s plus 1 into 1. So that's 1 here plus s into s plus 1 minus 3 into s plus 1. Like that. Yeah, I believe. So this is y of s into s squared minus 3s plus 2. And that is equal to 1 plus s squared plus s uh minus 3s minus 3s minus 3 again minus 3s minus 3 all over s plus 1. Okay, so we still tidy things up. So y of s into s squared minus 3s plus 2 is equal to s squared. S minus 3s is minus 2s. Then 1 minus 3 is minus 2, right? I think that works. All over s plus 1. So we have y of s now equals, we can divide through by s squared minus 3s plus 2. So this is like s squared minus 2s minus 2 all over s plus 1 into s squared minus 3s plus 2. So from the look of things here, this expression is factorizable, okay? So that looks like s minus 1, s minus 2, right? Because that will be s squared minus 3s plus 2, yeah? So that's what that should be. So we can have y of s now is equal to s squared minus 2s minus 2 all over s minus 1, s minus 2 into s plus 1. Okay, that's what we have there. So this is the tidy expression we can work with. So we now have to resolve into partial fractions. Okay, let me switch over to black. So resolving y of s into partial fractions. Okay, so we have y of s to be such that y of s is such that we have, the bottom is all linear, right? So we have s squared minus 2s minus 2 all over s minus 1, s minus 2, s plus 1. That will be similar to a over s minus 1 plus b all over s minus 2 plus c all over s plus 1. So we can multiply through by the LCM. So we have s squared minus 2s minus 2 equals a into, s minus 2, s plus 1, because s minus 1 cancels out. So b into s minus 1, s plus 1, because s minus 2 cancels out, plus c into s minus 1, s minus 2. So using the cover-up method now, like we always do, using the cover-up method, it's basically uh, putting up values to eliminate some values. Using the cover-up method, okay. So first of all, if you want to eliminate, but we already see, if you can equate this whole expression to 0. So any values you get there, if you put that value in, you are going to be able to eliminate something. So we can substitute 1, we can substitute 2 and minus 1. So let's start with minus 1. So for s equals minus 1, that's going to eliminate anywhere there is plus 1. So we see that this is minus 1 squared. S on the left hand side, we have minus 1 squared minus 2 minus 1 minus 2 equals, on the right hand side, we have a into minus 1, right? So that's minus 1 minus 2, then minus 1 plus 1. So automatically that will go, because minus 1 plus 1 is 0, then plus b into minus 1, then minus 1 plus 1. This will also go because minus 1 plus 1 is 0. Then the last one, we have to pay attention. So c into minus 1 minus s is minus 1, right? So minus 1, okay. Then now into minus 1 minus 2. So that's where we have the issue, the result, right? So this is 1 plus 2 minus 2 equals c into minus 2 into minus 3. So this is 1 here equals 6c. So that means that 6c is equal to 1 all over 6. So we have that sorted. Then next we have so we can use, we've used minus 1 already. Then we can use 1, all right? If we use 1, we can get rid of anywhere there's s minus 1. So we go for, so for s equals 1, so for s equals 1, on the left-hand side, we have 1 squared minus 2 into 1 plus 2, right? Oh, I mean, it's minus 2 still. So that's minus 2, right? Yeah. Yeah, that's minus 2. And that is equal to s equals 1. So to save time, anywhere there is minus 1, I'll just skip it. So you can see that b will go and c will go. Because if you put 1 here, this is 0, this is 0. So b and c will go. So let's focus on just a. So we have a. So this is equal to a into s is minus 1. S is 1, right? So we have a into 1 minus 2, 1 plus 1. So 1 minus 2 into 1 plus 1. So this is 1 minus 2 equals a into minus 1 plus 2 here. So this is minus 3, I believe. Okay, that is minus 3 equals minus 2a. Okay, so that means that a is equal to 3 all over 2. We have that. Then the other one, we can just put, if we put s to be 2, we can also eliminate a and c, and we have b. So um so at s equals 2, on the left hand side we have s squared. So that's 2 squared minus 2 2 minus 2, right? 2 squared minus 2 2 minus 2. So, and that will be equal to, on the right hand side, anywhere there's s minus 2, that will cancel out. So this should go, and this will also go. So we have only b left. So we have b into 2 minus 1, 2 plus 1. Okay. So b into 2 minus 1, 2 plus 1. So that is 4 minus 4 minus 2. And that is b into 1 into 3. So that is minus 2 equals 3b. So that means that b again is, b will be minus 2 over 3. So we have our results. In this case, now we can then rewrite. We can then say, so y of s, so y of s is equal to, a is 1 over 6, I think. No, a is 3 over 2. So that's 3 over 2 s minus 1. So this will be 3 over 2 all over s minus 1. Okay. Maybe without the bracket, 3 over 2 all over s minus 1. That is A. Then B is minus 2 over 3. B is minus 2 over 3 all over s minus 2. Okay. Minus 2 over 3 all over s minus 2. And C is 1 over 6. So that's plus 1 over 6 s plus 1. So we can just yeah, I don't even think we need to tidy it up for that, because all those numbers can go out and then we can take care of the rest. Okay. So what do? We now go for the inverse. We go for the inverse. Taking the inverse, the inverse Laplace transform, taking the inverse Laplace transform, we now have Laplace inverse of y of s equals, on the right, I'll just go straight. We have 3 over 2 inverse Laplace of 1 over s minus 1 plus, I think the next one is minus 2 over 3. Is it 2 over 3? Yes, it's 2 over 3, yes. And here it's 3 over 2, correct. Then minus 2 over 3, the inverse Laplace of 1 over s minus 2. Then lastly, plus 1 over 6, the inverse Laplace of 1 over s plus 1. So if we do all that, we just know that this left-hand side is y of t, and that is equal to 3 over 2. For s minus 1, we simply have e raised power, s minus 1. How does that go again? That would be e raised power t, okay? If it was just, if it was, yeah, if this was minus a, right? It would be plus up here. So this will be 3 over 2 e raised power t, then minus 2 over 3 minus 2 over 3 e raised power 2t, okay? Then plus 1 over 6 e raised power minus t. And that is exactly what the result looks like. So that's what we finally have. This is the result for that particular situation, barring any mistakes that might have happened in the previously. But I think everything is cool from what based on what I think. So the Laplace transform method efficiently solves the second order differential equation. So that's how that goes. So let's take some practice questions. Okay, practice. Solve using the Laplace transform. Okay. Number 1, y prime prime plus 4y equals 0. Y of 0 equals 2. Y prime of 0 equals minus 1. Question 1. Question 2, y prime prime minus 5y prime plus 6y equals 0. Then y of 0 equals 1. Y prime of 0 equals 0. Question 3, y prime prime plus 2y prime plus 2y equals 0. Y of 0 equals 0. Y prime of 0 equals 1. Question 4, getting tougher. Y prime prime plus y equals sine t. Y of 0 equals 0. Y prime of 0 equals 1. Question 5, y prime prime minus 3y prime plus 2y is equal to e raised power minus t. Y of 0 equals 0. Y prime of 0 equals 1. 6, y prime prime plus 4y prime plus 4y equals e raised power minus 2t. Y of 0 equals 1. Then y prime of 0 equals 0. Number 7. Okay, let me stop at number 6. I think number 7 and 8 would require some very advanced thing that we'll teach later. So let's start with number 6. So let me see your questions in the comment section, either on Facebook or on YouTube. Let me also see in the comment section if you have how helpful these videos are for you. All right, and let me know if there's a topic you'd like me to teach you, a problem you'd like me to solve. Then if you have not subscribed to the channel, please go ahead and do that. For those who have subscribed, thank you so much. And everybody, don't forget to hit the notification bell so you can always get alerted each time a new video is released. There's a lot of videos for your learning, going to 700 already. So you have a whole lot: probability, statistics, linear programming, scientific computing with Python, matrices, basic calculus, vectors, probability. I think I've mentioned probability, I don't know, and so on and so forth. So there's a whole lot: graph theory, network theory. So don't forget to like and share also so that more people can have access to this great content. And feel very free to share among your network. You have friends, uh, s- children, parents, whoever that need all this math stuff. So feel free to share this channel with them. Till I come your way again, keep doing math right. Bye.